Hello, in this segment, I want to talk about the suffix of move statement. If you look at here, move, I ended with the L, right? 1, 2, 3, 4 bytes of FF move to ECX. Okay. So in this case, the value of ECX is in binary 32 ones, right? That's the meaning of all these FFs. Okay. Now, let's do one more thing. Let's say I do move. I don't put any suffix. I just say move, say, for example, 0 to ECX. Okay, the question is, will it put 0 only for the least significant byte, meaning all of these will remain FF and change this byte to 0? That's the first question. Let's check that. Let us compile this, right? And see the outcome. We load it into GDB, disassemble the code, and look at the state of the ECX register after the second instruction. Okay, now we print the state of the register. We see 0. Okay, so that means all the bytes of ECX have become 0. Okay, what is the reason? If you don't put any suffix, right, it's assumed to be movl on a 32-bit machine based on ECX register, which is supposed to hold 32 bits. Okay, that is the reason why we get 0 to ECX, although in the previous statement, ECX has 32 ones in binary. Okay, now let's quit this code and do some more modification, right? What happens if I put movb? Okay, in this case, it's going to be fascinating to see. Let's compile and look at the outcome. We get a warning. Since I used movb, the warning says use CL register instead of ECX register. But for now, let's ignore the warning, which is not a good idea in general, but for now, let's ignore and go ahead and compile and link. Load this into GDB, right? And disassemble the start function and put a breakpoint at the same location. Let's print the content of ECX. What you see now is different. ECX was filled with all ones, right? But then we said, just update the lower portion of ECX register, meaning the least 8 bits of ECX register, that's called the CL, is updated by 0. Okay, that means the remaining 24 bits remain the same. That is the reason why you're seeing ECX has 24 ones followed by zeros, or equivalently FF, FF, FF followed by 0, 0, 0. Okay. All right. Now let's go back and do one more change. What if I do movw here? Instead of B, I put W. You get a warning. We should have used CX instead of ECX. That is the warning. Let us ignore that warning for a moment. Load it into GDB. Disassemble this and put a same breakpoint third statement. Run and look at the state of ECX. What you see here is fascinating. Only the first 2 bytes remain the same. The remaining 2 bytes have become 0. The reason is that we did movw. Okay, when we wrote our assembly code, we said movw, but the assembler generated move to CX. CX stands for the 2 least significant bytes of ECX. That's the reason why the remaining parts are not zeroed out here. Okay. Very nice. So if you remove this, of course, we talked about this, everything will become 0 because all the 4 bytes are going to be 0 because of movl. Okay. So we learned a few things. We learned what is movl, movb, and movw. Okay. If you don't put any suffix, it's assumed to be automatically detected based on the length of the register that we are dealing with. Okay, ECX can handle 32 bits. Therefore, 0 will be placed as a 32-bit 0, not a single byte. Although 0 can be represented in a byte.